All right, for the lesson today, we're going to talk about domain again, but we're going to talk about domain algebraically. We're going to talk about how to use an equation and apply some restrictions, and we will still verify it graphically using Desmos. So I have Desmos pulled up, and I have my notes so that we can see both of the screens here. So when we talk about domain, we talk about the values of x. So when we talk about the values of x, we are going to assume that my domain is all real numbers. Now, when we talk about all real numbers, that's the same thing as me saying from negative infinity to positive infinity. But every equation has restrictions that we can identify. So restriction one is if I have a fraction. And why is that important? Well, you can't have a denominator in a fraction equal to 0. So if I have a denominator, then I have a restriction. Okay, and if we have that restriction, then we're going to set that denominator equal to 0. Or set it not equal to 0 because it cannot equal 0. Restriction 2 is a square root. If I have a square root of any kind, then my square root cannot be negative. Remember, if I have a negative square root, that's an imaginary number. And we can't have that when it comes to the domain. So when we have the square root, it has to be greater than or equal to 0. Well, it has to be greater than 0 because it can't be negative. But it can be equal to 0 because you can take the square root of 0 and still get 0. So that's restriction number 2. Now the third one is a combination of both. So what happens if I have a square root and I have it in the denominator? Well, it still has to be greater than 0, but the difference here is that it cannot equal 0. Why can it not equal 0? Because it's in the denominator. So we're going to look through some examples and apply these restrictions. So when I'm looking at my first example, I have y equals 7x plus 4. Now, I'm going to assume that the domain is negative infinity into infinity unless it has restrictions. So I ask myself, does it have a fraction? No, so that's not a restriction. Does it have a square root? No, and doesn't have a combination of both. So automatically, my domain for this problem is going to be negative infinity to infinity just by looking at the equation because it doesn't have restrictions. And then, of course, I can graph it. I've already got my equations for my examples plugged in, so I'm just going to click them on and off. I can see it's a line, and I can see that it goes from negative infinity to positive infinity. All right, so looking at number 2. Number 2, I have a square root. So remember, if you have a square root, whatever is in the square root cannot be equal to 0. So my inside is 3x minus 12. So 3x minus 12 has to be greater than or equal to 0. So I'm going to solve this inequality. This inequality is going to tell me how my domain is going to look. So I'm going to start by adding 12 to both sides. So 3x is greater than or equal to 12. And then I'm going to divide by 3. So x is greater than or equal to 4. Now if I look at this graphically, I can see that my value starts right here at 4 and it's going to go greater than to the right side of my graph. So I can verify that that is a true statement by looking at it graphically. I can see that it's starting at 4 and it's going to positive infinity. So my domain for this one is going to be 4 with a bracket and to infinity. All right, looking at number 3, I have a fraction for this one. So when I have the fraction, I'm going to be able to just say that my denominator cannot be equal to 0. So I'm going to do just that. I'm going to take my denominator and I'm going to say that x minus 3 cannot equal 0. And I'm going to solve this one. So I'm going to add 3. So I know that x cannot equal 3. Or excuse me, yes, 3. So what does that mean? Well, we said we assume that the domain is negative infinity to infinity. But in here, I've now said that it cannot be equal to 3. So if I look at this graphically, I can see my graph here. I can see that it does have, it's an infinite discontinuity, But I can also see that as I'm moving it along my line, I can see that it's going to approach 3, but it's never going to actually cross at 3 for my graph here. So I'm looking at this and I can see that I have a vertical asymptote at 3. So if I have a vertical asymptote at 3, then my domain here is going to be, I'm going to start my domain over, and this is going to be negative infinity to 3 because it can't be equal to 3, parentheses, and I'm going to pick back up on the other side of 3 and then go to positive infinity. So when you have a not equal to, you're going to take that not equal to and you're going to split up your domain that was negative infinity to positive infinity. All right, so for number 4. So number 4 is that combination of the two. So I have a square root and I have a denominator. So I have both of them down here at the bottom. So that's going to tell me that if I have a square root in the bottom, that it is going to just be greater than 0. Why is it just greater than 0? Because it can't be equal to 0 because it's in the denominator. So I'm going to take x minus 9, and I'm going to say x minus 9 has to be greater than 0, but it can't equal 0. All right, so I'm going to solve it. I'm going to add my 9, and x is greater than 9. All right, so if I look at this graphically, I'm going to turn that one on, and I can see that x is greater than 9. So when I'm looking at it, I can see that there's a vertical asymptote. I can see that it's going to keep approaching that value of 9, but it's never going to actually cross over at 9. Now, because it's not equal to, the domain is not going to have a bracket this time. It's going to have a parenthesis. So it's going to start at 9 and go to infinity. So no bracket. We have to use parentheses because it's not included from 9 to infinity. All right, so now we got to do a little bit of graphing here. Or not graphing, excuse me. We got to do a little bit of factoring, okay, because I do have a fraction. And in my fraction, I know that it cannot equal 0. Well, I'm going to have to do something with that denominator because I have a trinomial right now. So if you remember, we learned how to factor in Math 1 and Math 2 and Math 3. So we're going to factor this. And if you can remember that this has an a value of 1, a b value of -3, and a c value of -10. So what we want is we want to know what numbers multiply to give me c, but they add to give me b, and my b value is -3. So I want two numbers that multiply to give me -10, but then add to give me -3. Well, you only got a few options. So I have 1 and 10. There's no way that I can add 1 and 10 to give me 3. So we're going to leave those alone. And then we have 2 and 5. Well, 2 and 5 definitely can work, but we got to figure out the right combination. So if I do -2, that's going to give me +3 when I add them together. So the only way to get a -3 is if I make my -5, or my 5 negative. So when I rewrite this, I have x plus 2 over x minus 5. Now, why did I want to do that? Because I can now split these two values up. And I can say x plus 2 can't equal 0, x minus 5 can't equal 0. So we're going to have two numbers that my domain cannot be equal to. So x, if I solve this, I'm going to subtract 2. So x cannot equal -2, add 5, and x cannot equal +5. So when I look at the actual graph of this, let me turn the other one off, we can kind of look at our pieces here. So I clearly can see that I have a vertical asymptote at -2. So we know that it can't be equal at -2. So what about 5? Well, I'm going to move my cursor along the graph here, and if I get to 5, I can see that I have a hole there. It's undefined. So Desmos is not going to openly show you the hole, but if you go find that value, it will show you the hole using the undefined part for the y value. So I do have two values that it does not equal. So when I look at it, my domain here is going to come from negative infinity, and I'm going to go up to that vertical asymptote at -2. Then I'm going to jump over to the other piece, and I'm going to go to -2 to 5. And then I'm also going to go to the other side of 5 and go to infinity. So let me kind of show it to you graphically for a second. So we're going down our problem. So negative infinity, we're going to positive infinity, but we see that we're going to approach that -2 value. So now it's going to jump over to the other side, and I'm going to go from -2 until I get to 5, and there's a hole there. So I'm going to start back on the other side of 5 and then go to positive infinity. All right, so for number 6, this got a combination of both. So this time we're going to have to look at the combination here. So I have the square root and I have the denominator. So the first thing I'm going to do is I'm going to factor that denominator. So I need to know what multiplies to give me 2 but adds to give me 3. So we should be able to see that that's 1 and 2. So this is going to simplify to x plus 1, x plus 2. So we're going to have to do kind of multiple parts here. The first part is going to be the square root. So in my square root, we know that that has to be greater than or equal to 0. I also have two parts in the denominator, and that denominator cannot equal 0. So we're going to say x plus 1 can't equal 0. And x plus 2 can't equal 0. So we're applying 3 restrictions in this particular example. So when I start with the first one, if I add 3, so x has to be greater than or equal to positive 3. All right. Then I see that I have a restriction that x can't equal -1. And I see that I have a restriction that x can't equal -2. So let's look at this graph. We got a lot to analyze here. Now, it says in my problem that x has to be greater than -3, or excuse me, positive 3. So we can see that that graph, if I try to move my cursor, is not going to go any farther to the left than 3. So if it doesn't go any farther to the left than -3, then I don't even have to worry about these other values because I'm already excluding those by using this particular piece. Because x can't equal -1 if it has to be greater than 3. X can't equal -2 if it has to be greater than 3. So my domain for this one is going to be bracket, because it does equal 3. I don't get it undefined. So 3 to positive infinity. All right, number 7. So I have a denominator and I have a square root. So this time we're gonna say that it has to be greater than 0 because it can't be equal to 0 in the denominator. So I'm gonna take that square root that's inside and I'm going to say that it has to be greater than 0. So from there, I'm gonna solve my problem. I'm gonna solve my inequality. So I'm gonna subtract 20. Now, this is very important. So this is like you having to think all the way back to Math 1 here. When you divide this problem right here by negative, you have to flip the sign. So when you divide by negative, you have to flip the sign. So instead of it being greater than, it's now going to become less than, positive 4. And if x is less than 4, so let's look at the example, and you can actually see that it's going less than. It's not going greater than. I can see that I'm coming from negative infinity, and the has a vertical asymptote at positive 4. So the domain here is going to be negative infinity to 4, and it's an asymptote, so it's not going to equal 4, and you're going to have a parentheses. So if you hadn't flipped the sign, you would have had greater than, but greater than wouldn't have matched your graph. All right, last one, we got a big combination here. So again, we have a denominator and a square root, so we know that it has to be greater than 0. But we got to factor this. Now, if you notice in the problem, I have a negative in front. I need to factor out that negative. So when I factor this, I'm going to factor this so that I pull out a -1. When we factor using that X chart, it's much easier if you go ahead and pull that -1 out of the problem. So that's going to leave me with positive x squared, -2x minus 15. Okay? And then all we have to do is factor this part. Alright, so we are going to factor that by using your X chart. So remember, we want the multiples of -15, but they have to add to give me -2. So we have 1 and 15. 1 and 15 definitely can't give me 2, so we're going to forget about those. Then we have, 3 and 5. 3 and 5 most likely will work. We'd have to make that 5 negative. So we're going to say, in this problem, we're going to take that square root. So we're going to say x, oh, don't forget my -1, it's still on the outside. So x plus 3 and x minus 5. So now we're going to take our two pieces that have an x variable, and we're going to say x plus 3 is greater than 0, x minus 5 is greater than 0. Alright, so for this one, I have subtract 3. So this one says that x has to be greater than -3. And this one says x has to be greater than +5. So we got kind of two inequalities that are battling each other right now. So let's look at the graph and let's see which one is going to give me what I'm looking for. So when I look at this problem, I can analyze what's kind of happening here. So when you have two inequalities, you can't trust the inequalities and their direction. The reason that is because technically it was one inequality initially, and now you've split it into two and you've kind of changed the mathematical properties of it. So I always recommend to look at it graphically. So we can see that we have a vertical asymptote. This one right here is going to continue to approach that -3 value, and this one over here is going to continue to approach that +5 value. But the inequalities are not going to match up in my problem. The only thing that's going to match up is the actual values that we're looking at. So we're going to need to look at it graphically, and we're going to have to determine that my values are going between -3 and 5. So my domain for this one is -3 to 5, is going in between those two values. Now, with these restrictions, I know some of the things like factoring, you may have to kind of remind yourself. Hopefully, by doing a few up here that you have refreshed. If you have any questions, let me know. And we will revisit this when we get to our rational functions, but I thought it was a good idea, since we were talking about domain, to go ahead and talk about an algebra.